Hello everybody, and welcome to exercise 1 on page 29 of the workbook here. Let's take a minute to read this question together. So after t minutes, the temperature of a potato that has been placed in an oven is given by H equals F of t degrees Fahrenheit. Suppose that it is given that F of 64 equals 330.28 and F prime of 64 is 1.341. Okay. Now here's another question where they don't give us a formula or a graph, but we can kind of think generally about what a graph might look like here. So notice that if you take a look at the kind of the general form of the function, we've got an input variable of t, that's representing time in minutes, and our output is h, that's temperature in degrees Fahrenheit. Okay, and we'll maybe refer to that picture as we go through the question just to help us answer these questions. All right, so let's start with A here. So they want to know what are the units on the numbers 330.28 and 1.34, okay, and then to explain the meanings of the statements that involve those two numbers. All right, well, let's start with the first of the two numbers, the 330.28. That came from substituting 64 into our function. So notice that that's just an ordinary output of our function. Okay, so its units should match the units of h, which are degrees Fahrenheit, looking up at the little graph that we drew. Okay, so we might start by attaching those units. Okay, let's go ahead and write an interpretation now that we've got this down in front of us. Okay, so the temperature of the potato is 330.28 degrees Fahrenheit at t equals 64 minutes. Okay, so 64 minutes after the potato was put in the oven. Okay, and then what about the next number, the 1.341? Well, that was a value of the derivative, so let's think about units there. Okay, so f prime of 64 equals 1.341. So a derivative is about a rate of change, and in this case we're measuring the rate of change of temperature with respect to time. So the units should be units of rise, which is degrees Fahrenheit, over run, which is minutes, looking at our graph at the top here. So the units of that should be degrees Fahrenheit per minute. And how would we explain that statement in words? Okay, well, it's telling us about a rate of temperature change at the time 64. So 64 minutes after the potato is placed in the oven, its temperature is decreasing at a rate of, or I'm sorry, not decreasing, increasing. Okay, I don't know where I came up with the idea of, okay, I think I'm thinking about an earlier problem here. So the temperature is actually increasing because the derivative is positive. Its temperature is increasing at a rate of 1.341 degrees Fahrenheit per minute. Okay, which makes sense because if we're putting the potato in the oven, its temperature should go up. Okay, so I think we've answered part A. There were several questions there. What about part B? Okay, so now they're asking, what do we expect the temperature of the potato to be when t equals 65 and when t equals 66? So we're kind of being asked to predict what the temperature would be a little bit later than this time of 64. Okay, so I like to draw diagrams. I'm going to start by drawing a little diagram here. So we might start out by thinking about, well, we're comparing time and temperature here. So how about if we do this? So we'll put times down here, 64 minutes. That's kind of the starting time if you want to think about it. We know what the temperature of the potato is at 64 minutes. That was the number that they gave us up here in part A. So I'll write that temperature up above. And what we're being asked to estimate is what would happen if we went 1 minute forward in time to 65 minutes, and then another minute forward in time to 66 minutes. Could we predict the temperatures at those two times? Okay, well, the question then is, how much does the temperature increase during those time periods? We can get our hands on that number by looking at our derivative. This tells us, okay, looking back at part A, how many degrees Fahrenheit per minute the temperature, or how many degrees Fahrenheit the temperature should increase per minute that goes by. That was the meaning of that derivative. So if we want to know what's happening at t equals 65, what we could say is, okay, we know that we started with a temperature of 330.28, and we know that the temperature is going to increase by about 1.341 degrees Fahrenheit because 1 minute of time went by. Okay, so if we take those and add them, we're going to get 331.621. Oh, whoops, 621. And that would be our best estimate of the temperature at t equals 65. Okay, well, what about at t equals 66? Well, now we've moved 2 minutes forward in time from t equals 64, so we would expect double the temperature increase. So we're going to take this 1.34 that we had here and just double it. So we'll get 330.28 plus 2 times 1.341. Okay, and that's going to give us 332.962 degrees Fahrenheit. Okay, and that's our temperature estimate at t equals 66. Okay, let me be a little bit more careful with how I'm writing that. Temperature estimate at t equals 66. Okay, and this is just an approximation, so actually up here I should have also said estimate. We don't know for sure that that's exactly the temperature, but that's our best estimate based on the data that we have.